Hello, and welcome to another episode on the Total Space Network. I'm Mikko, the host of Deep Dive Fridays. It has been a couple of exciting weeks on Mars. Just yesterday, the Mars 2020 rover named Perseverance touched down successfully on the Red Planet. And last week, I took a deep dive into Emirates' Mars mission called Hope. This week, we are checking out the Chinese Tianwen-1 mission, which successfully entered the orbit of Mars last week, just after the Hope orbiter. The Chinese Tianwen-1 mission is maybe the most ambitious of all three Mars missions this year. Hope has an orbiter and Perseverance is a rover. But the Tianwen-1 mission tries to accomplish three goals with one mission. There is the orbiter that has already entered Mars orbit. Then there is the lander, which is supposed to land in May 2021. And in the lander, there is a rover. This is a very complex mission for a country who hadn't even been to Mars orbit before this mission. But I do have a feeling China may just be able to complete this mission without a hitch. They have landed on the moon 3 times, all missions being successful. And last of them landed on the moon last December for a sample return mission that was completed successfully. And for added complexity, the lunar sample return mission did an orbital rendezvous, docking 2 vehicles in lunar orbit before sending the sample back to Earth. So yeah, let's drill deep into the details of this mission. Tianwen-1, or Heavenly Questions in English, is an interplanetary mission to Mars by the China National Space Administration, or CNSA. With a total mass of just about 5 tons, this is one of the heaviest probes ever launched to Mars, and it includes a whopping 13 science instruments. Lucky number or not. The mission was successfully launched from the Wenchang spacecraft launch site on July 23rd, 2020 on a Long March 5 heavy lift launch vehicle, and this is a good time to comment the launch vehicle itself. It hasn't flown too many times, Tianwen-1 mission being the 4th flight of this configuration. First ever launch of this vehicle was a success, but the second one failed, so China needed to get this operational before the Mars mission. And the third launch was a success in late 2019. And a slightly different 5B variant of this rocket flew just about 2 months before Tianwen-1. And that mission took a Chinese future crew capsule to low Earth orbit. But the rocket itself can lift around 25 tons to low Earth orbit, 9 tons to translunar injection and 6 tons to transmars injection. So the 5-ton payload was pretty close to the limit on what it can send to Mars. This is also one of the only Chinese rockets not using hypergolics, but instead the good old regular LOX with RP-1 on 4 of the boosters and liquid oxygen plus liquid hydrogen on the first and second stages. And after about 7 months of transit time, Tianwen-1 entered Mars orbit on February 10th, 2021. And this is the time when China became the 3rd nation to get into the orbit of Mars on the first try. And in total, I think China is now the 6th country after UAE to actually get into the Mars orbit. And before that, there has only been Soviet Union, United States, Europe, as in United Kingdom, and India. And after the launch, Tianwen-1 traveled just about 7 months before entering Mars orbit on February 10th, 2021. By performing a burn of its engines to slow it down just enough to be captured by Mars's gravitational pull. This was a long burn, almost 15 minutes of the engine with 3,000 newtons of thrust. And CNSA released awesome video of still pictures of the burn made into a video. You can actually see the engine burn giving some vibrations to the orbiter. The insertion burn placed Tianwen into an elliptical orbit of 400 by 180,000 kilometers with an orbital period of 10 days. As with all Mars missions, the burn was pre-programmed and all you could do was wait for the telemetry. Orbiter will gradually lower its orbit to get better observations of Mars and mapping landing site for the rover in Utopia Planitia. According to spacenews.com, the landing site coordinates of 110.318 degrees east longitude and 24.748 degrees north latitude had been seen in the official Chinese publications but deleted since. I guess we'll see the coordinates when it lands in May or June. The lander is projected to make an atmospheric entry followed by a descent phase under a parachute, after which the lander will use its propulsion to land smoothly on Mars. This is actually starting to sound not too different from the Perseverance landing, excluding the sky crane with AI mapping of the surface, which are replaced by the rocket engines on the lander and pre-mapped landing site data from the orbiter. If all goes according to the plan, the lander will then deploy the rover designed to explore the surface for 90 Martian days, or sols. We all know NASA and CNSA set such low numbers just to amaze people after 15 years and a marathon of operating time. The rover itself is only about 240 kilograms in weight, while Percy is 4 times that at over 1 ton. The rover is actually fairly big at 2.6 times 3 times 1.85 meters, so not that much smaller than Percy. And the orbiter will serve as a telecommunications relay during the rover's primary mission and will position itself in an orbit more conducive to observations while retaining its role of relay. Orbiter will have 2 scientific orbits, first one being an 8.2 hour 400 kilometer times 15,000 kilometers orbit, and final orbit being 265 times 12,000 kilometers with an orbital period of 7.8 hours. Aside from the obvious mission objectives of validating the communication and control techniques in deep space, getting in orbit around the planet and landing on Mars' surface, the orbiter will also make it possible to locate a site for a future return of Martian samples. The following scientific objectives must be met: study the morphology and geological structure of Mars, as well as its evolution and its causes. To do this, the probe will analyze the topography of the planet with precise data from characteristic regions such as the dry bed of rivers, the reliefs of volcanoes, wind erosion, glaciers at the poles, etc. The 2 cameras present on the orbiter are dedicated to this objective. Second objective is to study the characteristics of surface and underground layers of the Martian soil, as well as the distribution of water ice. This is the role of the radars present on the orbiter and the rover. Third objective is to study the composition and type of rocks, as well as minerals and elements present on the surface of Mars. Analyze the carbonate or weathering minerals present in ancient lakes, rivers, and other landscapes resulting from the past presence of water on the planet, such as hematites, lamellar silicates, sulfate hydrates, or even perchlorate minerals in order to establish the link with the watery past of Mars. The spectrometers on board the orbiter and the rover, as well as the multispectral camera, are dedicated to this objective. Fourth objective is to study the ionosphere, the climate, the seasons, and more generally, the atmosphere of Mars, both in its near space environment and on its surface. This is the role of the two particle detectors present on the orbiter as well as of the rover's weather station. Fifth objective is to study the internal structure of Mars, its magnetic fields, the history of its geological evolution, the internal distribution of its mass, and its gravitational field. The magnetometers as well as the radars present on the orbiter and rover are dedicated to this objective. And also, the aims of the mission include searching for evidence of current and past life, producing surface maps, characterizing soil composition and water ice distribution, and examining the Martian atmosphere and in particular its ionosphere. The mission also serves as a technology demonstration that will be needed for an anticipated Chinese Mars sample return mission proposed for the 2030s. Tianwen-1 will also cache rock and soil samples for retrieval by the later sample return mission. Sound familiar? Percy is doing the same thing. And as mentioned earlier, to complete these objectives, the mission has a total of 13 instruments, of which 7 are on the orbiter and 6 on the rover. On the orbiter, there are medium resolution camera or MRC with a resolution of 100 meters from a 400 kilometer orbit. Then there's high resolution camera HRC with a resolution of 2 meters from a 400 kilometer orbit. Third instrument is Mars magnetometer. Fourth instrument is Mars mineralogy spectrometer or MMS to determine the elementary composition. Fifth instrument is orbiter subsurface radar or OSR. Sixth instrument is Mars Ion and Neutral Particle Analyzer or MINPA. Seventh instrument on the orbiter is Mars Energetic Particle Analyzer. And on the rover there is Ground Penetrating Radar or GPR to image about 100 meters or 330 feet below the Martian surface. Second instrument is Mars Surface Magnetic Field Detector or MSMFD. Third instrument is Mars Meteorological Measurement Instrument or MMMI. Fourth instrument is Mars Surface Compound Detector or MSCD. Combines laser-induced breakdown spectroscopy and infrared spectroscopy. Fifth instrument is Multispectrum Camera or MSC. Sixth instrument is Navigation and Topography Camera or NTC. Personally, I can't wait to see the landing of Tianwen-1 and the data the instruments provide. Hopefully the data will be shared freely worldwide. So, what's your favorite mission of this year? And will we find life on Mars? Tell me in the comments if you are watching on YouTube. Otherwise, find and follow me on Twitter at Mikoske or Mikoske. And if you liked the video, please like and subscribe as well as share it with your friends. Don't forget to check out our other shows, The Space Update where Ryan gives you the latest news, and Becoming Multiplanetary with Rich and Kage. For example, on the latest Becoming Multiplanetary episode, we did a 90-minute long look into the Perseverance rover with our great guest, Dr. Graham Lau. Check it out if you haven't. Link is in the description. It was streamed live on YouTube. And if you are still listening, you probably enjoy our content, and why not think about supporting us on Patreon at patreon.com/totalspace. And The following is a group of awesome people who keep us producing content 3 times a week. And as always, our gratitude goes to Anthony Mann, Warhawk Me, Adrian Moisa, The Angry Astronaut, Howard Walker, Sammy Oscuro, What About It, Chixuan and Sebastian from To the Future, Gio Bagliari, Framric, Susie, and Marco. Thank you very much for listening and have a great day.